Calculus 1, limits with trig. I genuinely have no idea how to solve these. Only thing I know is that we cannot directly sub in 0 since that leads to an indeterminate answer. Okay, let's have a look. So to evaluate this kind of limit, notice that when we plug in 0 into all the x's, we will have 0 over 0. It's indeterminate. We cannot draw any conclusion. However, we do have the sign right here, right? So that's a big hint that we will have to use the following limit. Note, if we have the limit, let's say a variable theta goes to 0 of sine theta over theta, this right here gives you 1. This is a fact that you will have to know. This is one of the most fundamental limits that you will have to know before we do any L'Hopital's rule or derivative. So this is the idea. Well, how do we use it? First, notice that the input of the sine and the bottom have to be the same, and theta goes to 0. Here we have sine 3x. We have to produce this situation first. So let's go ahead and do this. We have the limit as x approaching 0. On the top, we have sine of 3x. I'm just going to divide every term by 3x. So I'll do it like this. And then 5x to the 4, I will also divide that by 3x. And then lastly, 3x divided by 3x as well. Now, this is going to be something like this, which is very nice. But before we do that, let's simplify the bottom. This is the limit as x approaching 0. Here we have sine of 3x over 3x. Reduce that, we will get 5 over 3. Exponent 4 minus exponent 1, we have x to the third power. And then this is just going to be 1. Now, we are in business because right here, we can do the following. We can say this right here is our theta. It's like we're taking the limit of the top and then the limit of the bottom. We can do that if the top and bottom both have limits, meaning that we get like finite values and good stuff. So on the top right here, you actually get 1 because if you want to put in more details, you will have to write something like let theta be 3x, and this limit sine of 3x over 3x will be the limit as theta approaching 0. Because x goes to 0, 3 times 0 is just going to be 0 for theta. And then we have sine of 3x, which is theta. On the bottom is also theta, so that's equal to 1. So the top, you can do the work right here on the side. You'll get 1. So this, taking a limit on the top is 1. And on the bottom, plugging 0 into here, 0 to the third power times 5 over 3 times 0. You can set it up first. Well, you can see that it's just 0 right here. And then plus this 1. So all in all, 1 over 1 is just 1 for the final answer. So that's the first one. Now for the second one, we have cosine, but the limit I told you it was with sine. So what can we do? Well, this right here, we have cosine x minus 1. So let's multiply the conjugate, top and bottom. We get cosine x plus 1, and then cosine x plus 1. This way, we will see the top is just going to be, you square the first term, which is cosine square x, and then minus square of the second. So it's cosine square x minus 1, right, if you multiply it out. And the bottom is this. Now this is just like cosine square x minus 1. I think we do have a very nice identity, right? So another note on the side. We know that if we have sine square x plus cosine square x, that is just equal to 1. Now I want to have cosine square minus 1, so I will bring this to the other side. We have cosine square x minus 1. That will be equal to bring the sine square x to the other side, which is negative sine square x. So the top right here is just equal to negative sine square x. And to make this super clear, I'm going to write it down like this. we have the limit as x approaching 0. We have negative sine square x, which means we have sine x times another sine x. And then on the bottom, we have this 2. And for the x squared, I'm going to break it down as x times x. And we still have this factor. Now, this is what we can do. A limit of a product, it's the same as the product of a limit if each limit exists. What we mean by that is just we can go ahead and do every part that by itself. For example, sine x over x, that's just 1. It has a nice answer, so we can do that. Likewise, sine x over x is just 1. And plugging 0 into here, we can work that out. I'm going to write down the detail right here later, but this is what you can write down. First, we have negative 1 over 2. And then next, sine x over x, x approaching 0, is the 1. And for the red one, we have another one. But don't forget, we still have this factor, which is 1 over cosine x, which we will just plug in 0. We get a nice number, so right here it works. This right here is 1. 1 plus 1 is 2. So we have negative 1/2 times 1 times 1 times 1/2. So we have negative 1 on the top over 4 on the bottom. And that will be the answer, just like that. Now, like I said, what exactly is happening is this. First, we can put the negative 1/2 is the constant multiple. Just put it on the outside. And then for this, we are really doing the limit as x approaching 0 of sine x over x. And then the red one, the limit as x approaching 0, sine x over x. And finally, one more limit as x approaching 0, 1 over cosine x plus 1. And then we just compute this, compute that, and compute that. And we got this, this, and that. So this is part B. I know there's also part C, but I would like you to try that. Leave a comment down below, let me know what the answer is. Hopefully this video is helpful, and let me know if you have any questions. And you can check out my other videos for more calculus tutorial. That's it.